All right. So our first day of semester 2 final review. I'm going to start with unit 7 in factoring. In unit 7, the very first thing we talked about was factoring using the greatest common factor. So just as a reminder, greatest common factor is the largest factor that all of the terms of a polynomial have in common. For the coefficients or the numbers, it's the largest number that divides evenly into all of the numbers. So you could list out your factor pairs and just find the largest number in those factor pairs. For the variables, it's the smallest exponent for each variable. All terms must have the variable in order to include it in the greatest common factor. So we're going to do this first example, part A, and factor 35x to the fifth minus 49x to the fourth minus 42x squared. And as I said, what we could do is list our factor pairs. 35 and 1. 2 will not work, 3 will not work, 4 will not work, 7 and 5. Those would be our only four factors. For 49, we'd have 49 and 1. And then the only other factor is 7 and 7. For 42, we'd have 42 and 1, 21 and 2, 14 and 3. 4 is not going to work. 5 is not going to work. 6 will work. We'll get 7 and 6. So if I look, the largest number in all three factor pairs is 7. So 7 is going to be part of our greatest common factor. Because our polynomial is written in standard form and there's only one variable, the variable term on the last term is going to be part of our greatest common factor. For the rest, so the greatest common factor would be 7x squared. If you wanted to write it in factored form, then for the rest, this first term, when we take out the 7, we would have a 5 left. That's the paired factor with 7. We took out x squared. We had x to the fifth. We can subtract those exponents. Be 5x to the third. For my second term would be minus 7x squared. And the last term would be minus 6. And there is our completely factored form for that polynomial. If we try number 2a, here we have a couple of different variables and some numbers. If we find the factor pairs, 1 and 40, 2 and 20, 3 doesn't work, 4 does, 4 and 10, 5 and 8, 6 doesn't work, 7 doesn't work. So there are the factor pairs for 40. For 12, 1 and 12, 2 and 6, 3 and 4. And for the other 12, 1 and 12, 2 and 6, 3 and 4. So the largest number that is in all three factor pairs, in this case, is 4. The greatest common factor for the a's is the smallest number of a's that appear in any term. So we have a to the third, a to the fifth, and a to the third. 3 is the smallest number. And for the b's, also the smallest number. So I have b or b to the first, b to the fourth, and then I don't have any b's in my third term. So there is not going to be a factor of b in my greatest common factor. What's left after we factor out that greatest common factor, I have a 10 in my first term. The a to the third got factored out, so I don't have a's, but I do have a b. In my second term, I have the 3 as the other part of that pair. I took out 3 of the a's, so there are 2 remaining, and I did not take out any of the b's. And for my third term, 3 is the other factor pair, and we took out the a to the third. So there is our factored form. When factoring quadratics, and we did several days of this, a couple of different sections, there's this wonderful flow chart that is great to follow. Check to see if there's a greatest common factor. Is the equation quadratic? How many terms does it have? What is the value for a? Is it a difference of two squares? If a is 1, try the x method. Otherwise, try the slide method. And then right next to it is the method that we called the slide method. And we'll see some of these as we go through our examples. So x squared minus 15x plus 54. There is not a greatest common factor other than 1. There are 3 terms. It is quadratic, and a is 1. When a is 1, we have the x method. So I need to find 2 numbers that multiply to positive 54 and add to negative 15. They have to multiply to a positive, so they have to have the same sign. They have to add to a negative, so they both have to be negative. And if you don't know, you can try listing factor pairs. -1 and -54, -2 and -27. And then just always check. If I add those together, do I get -15? So far, no. -3 and -18 still don't add almost to -15, but because they're the same side, it actually adds to -21. -4 is not going to work. -5 is not going to work. -6 and -9, and those do add to -15. So my factored form, x minus 6, x minus 9, and that's my answer. Remember, we're just factoring. We're not solving yet because it's not an equation. It's not equal to something. Letter B, x squared minus x minus 20. Find 2 numbers that multiply to -20 and add to -1. Again, they multiply to a negative, so we have to have 1 positive and 1 negative value. They add to a negative, so the negative value has to be the larger value. So we could try 1 and -20, 2 and -10. 3 doesn't work. 4 and -5, and that's the one that adds to -1. 4, -5. So our factors, x plus 4, x minus 5. For number 4, letter A, we have 4x squared plus 12x minus 112. So we have that number in front of the x squared, so I would check for a greatest common factor. And in this case, 4 divides evenly into all 3 of those terms, would leave us with an x squared plus 3x minus 28. What we have left in the parentheses has a coefficient of 1 for a is 1, and it's a quadratic. So find two numbers that multiply to negative 28 and add to positive 3. So negative 1 and 28, negative 2 and 14. 3 doesn't work. Negative 4 and 7, and that adds to positive 3. So my factored form, don't forget the 4 that's out front. And then we have x minus 4, x plus 7. For number 5 here, we have, again, a coefficient out front. So I check, is there a number that evenly divides into 4, 12, and 5 other than 1? In this case, there is not, so we're going to use the slide method. Take the 4, slide it all the way to the end, and multiply. So we have x squared plus 12x, and 5 times 4 is 20. At this point, it's going to look a lot like the x method. Find two numbers that multiply to 20 and add to 12. Both numbers have to be positive to multiply to a positive and add to a positive. So our factors, again, you could list your factor pairs if you wanted. 1 and 20, 2 and 10, and that's where we can stop because that adds to 12. But in order to get to that 2 and 10, we multiplied by 4. So now we need to divide by 4. Does 4 divide evenly into 2? Now be careful, it's 4 into 2, not 2 into 4. In that case, no. Then I look, can I reduce? Is there a number that evenly divides into both 2 and 4? And 2 divides evenly into both to give us 1/2. What that means is for our factor, the 2 that's in the denominator goes in front of the x. The numerator becomes our constant term. So 2x plus 1 would be that factor. Doing the same thing with the 10 over 4. Does 4 divide evenly into 10? No. Is there a number that divides evenly into 4 and 10? And the answer is 2. 10 divided by 2 is 5. 4 divided by 2 is 2. So my second factor is going to be 2x plus 5. Always the denominator going in front of the x and the numerator becoming the constant term. Then we had a couple of special cases. One was the difference of squares. If we have a perfect square minus a perfect square, it factors into the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. The other is the perfect square trinomial. Again, I would just use the x method for that one rather than trying to memorize that formula. So for letter A, 9x squared minus 100. 9 is a perfect square. Square root of 9 is 3. So we're going to end up with 3x plus something, 3x minus something. And the number that multiplies by itself to get to 100 is 10. In other words, the square root of 100 is 10. And there's our factored form. 4x squared minus 49. Square root of 4 is 2. X. Square root of 49 is 7. So 2x minus 7, 2x plus 7. Again, the order for the subtraction and the addition doesn't matter. You can do it like we did with example A, with the addition first and then the subtraction, or like we did with example B, with the subtraction first and then the addition. All right, and that takes us to Unit 8, quadratic functions. Given a graph, we're going to label the vertex, the axis of symmetry, the x-intercepts, and the y-intercept. So let me get the graph so that it's in the entire graph is in the screen. Perfect. Here's our vertex. It has coordinates -3, 4. The axis of symmetry is the vertical line that goes right through the vertex. Its equation is always x equals the x coordinate of the vertex. So that -3 just gets repeated. Our y-intercepts, our x-intercepts. We have an x-intercept at -5, 0. We have another x-intercept at -1, 0. And our y-intercept way down here, 0, -5. We talked about a couple different forms for quadratic functions. We started with vertex form, y equals a times x minus h squared plus k. The vertex for that quadratic, for that parabola, would be hk. For that vertex, we take the opposite sign that you see in the equation for our x coordinate, and k, we keep that the same sign as it is in the equation. When a is positive, our parabola opens up, and when a is negative, our parabola opens down. If the absolute value of a is greater than 1, our graph is narrower. It's a very narrow parabola. And if the absolute value of a is less than 1, then this is a wider parabola. It opens up very wide. Use the 1-3-5 pattern to plot more points. Now, don't confuse this one with the 1-3-5 pattern for radical equations. So for this one, it's over 1 up 1 times a, over 1 up 3 times a, over 1 up 5 times a. If you're given a graph, identify the vertex hk, start at the vertex, go right 1, and go up or down until you find your value for a. So finding the vertex. Well, we know the vertex is a point, has an x coordinate and a y coordinate. Always the opposite of the x part, so -4, and always the same y coordinate as what's outside. So -4, -8 for our first function. For our second function, opposite of what's inside. So we get +6. What's on the outside stays the same, +1. So 6, 1 for our second, our y coordinate for our second vertex. Graphing. So to graph, I would start with the vertex. And in this case, we get -2, 3. As soon as I know the vertex, I know the axis of symmetry. X equals -2. Looking at my equation, my value for A is -1. So my pattern is going to be over and down. So over 1, down 1, You could say -1 there. Over 1, down 3. Over 1, down 5. So that 1, 3, and 5, if you want to think of it as up, it's -1, -3, -5. And that's the way we go for the right side of our graph. Over 1, down 1. Over 1, down 3. And over 1, 1, 2, 3, 4. I can't go down 5. Because of that axis of symmetry, we get the mirror image on the other side of the graph. And so we get a graph that looks like this and a graph that looks like that. Right. Here is a graph. We want to write the equation in vertex form. So to write it in vertex form, I would find the vertex first. And just as a reminder, vertex form, a x minus h squared plus k. So let's find that value for a. I start at my vertex, I go over 1, and in this case, I go up 2. That is my value for a. The coordinates for my vertex are 1, 3. So I have x minus 1 squared plus 3. And that's my equation. Standard form, f of x is equal to ax squared plus bx plus c. Here, our axis of symmetry, we take the opposite of b divided by 2a. Once we find the axis of symmetry, that value is the x-coordinate of our vertex, just like it was if we had vertex form. And to find the y-coordinate, we plug that value into our equation and solve to get the y value. Again, we'll take a look at that here in just a minute. One of the nice things about standard form, the y-intercept, really easy to figure out. It is the point 0 and then whatever c is. The value for a works exactly the same in this form as it did in vertex form. So if it's positive, our graph opens up. If a is negative, it opens down. If the absolute value of a is greater than 1, we get a narrower graph. And if it's less than 1, we get a wider graph. And we can use the 1, 3, 5 pattern to plot points on each side of the vertex. And again, on a multiple choice question, I would start by looking for the y-intercept and then which way the graph opens, if it's up or down, and see if I can eliminate any multiple choice answers that way. So here we're just trying to find the vertex. So I would list A, B, C. A is 3, B is -12, C is -4. In order to find the vertex, the first thing I need to do is find the axis of symmetry. And that formula is the opposite of B over 2 times A. So I take the opposite of -12 over 2 times 3. The opposite of -12 is +12. 2 times 3 is 6. 12 over 6 is 2. So the x-coordinate of my vertex is 2. To find the y-coordinate, I take that 2 and I plug it in for x. So my y-coordinate is going to be 3 times 2 squared minus 12 times 2 minus 4. Remember your order of operations. So we have to square the 2 first. 2 squared is 4. Then we take 3 times 4, that's 12. Minus 12 times 2, that's 24, minus 4. And now I can subtract across. 12 minus 24 is negative 12, minus 4 is negative 16. So my vertex is 2, negative 16. Excuse me. So here's a graphing problem. Uh, graph each function, label the vertex and the y-intercept. So again, let's start with the y-intercept. It's easy if it's in standard form. The y-intercept is 0, negative 3, whatever this value is, that just goes in as the y-coordinate of the y-intercept. Then we can find the vertex. And to find the vertex, we start with the axis of symmetry. X equals the opposite of B over 2 times A. So again, it helps if you know A, B, and C. So we would get negative 2. 2 times a half is 1. So the axis of symmetry is at x equals negative 2. The vertex Mr. Gingrich wrote it wrong here. 2 times negative 2. There we go. Minus 3. So again, order of operations. We square the negative 2. Negative 2 squared is positive 4. Then we can do our multiplication. Half of 4, 2. 2 times negative 2 is negative 4 minus 3. 2 minus 4 is negative 2, minus 3 is negative 5. So our vertex is negative 2, negative 5. I'm going to use the symmetry here and graph the mirror image of my y-intercept. And then I'm going to use the pattern. In this case, A is 1/2. So I go over 1 up a half, then over 1 up 3 times a half, or 1.5. So there's a half. There's 1.5. Over 1 up 5 times a half, or 5 halves, or 2.5. 2.5. Over 1 up 7 halves, or 3.5. 2, 3, right there. And I can't do any more. And then I can actually only graph this point, the mirror image, and this mirror image point. And so my graph a little bit flatter than our normal parabola. The vertex was at negative 2, negative 5, and the y-intercept was at 0, negative 3. I believe the last um, form that we looked at was this thing called intercept form. I like to call it factored form. Um, Seems pretty straightforward to me anyway, because it's a factored quadratic. Our x-intercepts are p0, q0. So one way to think about that, take each of the factors and set them equal to 0 and solve for x. But also they're in parentheses, so it's the opposite. So we have minus p minus q, but for our intercepts, it's positive p0 and positive q0. The axis of symmetry, x equals p plus q divided by 2. It's halfway between our x-intercepts. And our vertex, we take that x value, plug it into our equation to find the y value to get our vertex. And again, the value for A acts the same way as it does in vertex form and standard form. Nothing new there. If you're given a graph and want to find the equation in intercept form, plug the x-intercepts in for P and Q, and then find A by starting at the vertex, going right one, and up or down until you get to the graph. So here it says find the vertex. In order to find the vertex, I'm going to start by finding the x-intercepts. And let's see, 0, 1. Sorry. 1, 0. Negative 5, 0. Knowing the x-intercepts, my axis of symmetry, x equals my x-intercept plus my x-intercept divided by 2. So 1 plus negative 5, negative 4 divided by 2 is negative 2. Now I can find the y coordinate for my vertex by plugging in negative 2 for x. So I do have that negative 2 out in front. I then get negative 2 minus 1 and negative 2 plus 5. Negative 2 minus 1 is negative 3. Negative 2 plus 5 is positive 3. Remember, when we're finding our vertex in intercept form, the two numbers in the parentheses are always going to be opposites. And then if I multiply, negative 2 times negative 3 is positive 6, times positive 3 is 18. So our vertex, negative 2, 18. Graphing in this form, I would first graph my x-intercepts. Negative 3, 0. Positive 1, 0. My axis of symmetry, x equals negative 3 plus 1 divided by 2, which is negative 2 divided by 2, negative 1. To find my vertex, I plug negative 1 in for x. 2 times negative 1 plus 3 times negative 1 minus 1. Negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. This gives me negative 8. Using the pattern, I'd go over 1 up 2, over 1 up 3 times 2 or 6, 1, 2, 3, 4, 5, 6, over 1 up 5 times 2 or 10. And so I have those values on my graph. And I can try to sketch that graph. There we go. A little bit better. For number 15, we're just selecting the equation below that matches each graph. It says find the x-intercepts and plug them in for P and Q, and that might help, and find A from the graph. So there are my options. Now, in this case, I know because it opens down, A has to be negative. So for this first one, I can eliminate 2 and 4. I'm not going to cross them out because you'll have to use those for the other one, possibly. My intercepts are -1, 0, and +3, 0. So that means I would have x plus 1, x minus 3. And I can see that that's option 3. If I want to just double check that A is 1 or -1, start at my vertex, go over 1, down 1. Yes, perfect. So that is equation 3. The last thing we're going to do, we're going to convert from, in this case, we're in vertex form. We want to go to standard form. So the first thing we're going to do, we're going to take x minus 4 squared. I'm going to multiply that out using the box method. Of course, you can use the FOIL method. You could also use the shortcut method, which we'll talk about a little bit later. X times x is x squared. X times -4, -4x. -4 times x, -4x. -4 times -4 is positive 16. Combine my like terms, I have a -4x and a -4x. That's a total of -8x. So where I have x minus 4 squared, I'm going to replace that with x squared minus 8x plus 16. And I have that plus 7 on the outside. Next, I need to distribute the 1/2. So I get 1/2 x squared. Half of minus 8x is minus 4x. Whoops, 4x. Half of 16 is 8. The last thing I have to do is add that 7. 8 plus 7 is 15. And there's that same equation, just written in standard form. That concludes day 1. Go back now and finish the problems that are not double starred. And that's your homework. And tomorrow we'll start on problem 17.